Good morning, good evening, or good afternoon, depending on where you're joining us from today, and thanks for attending today's session, Build Innovative Real-Time App Experiences with Azure Cosmos DB. Before we get started, I'd like to go over a couple of housekeeping items. If you look on the right-hand side of your webinar screen, you should see a few resources that we've added that we think you might find helpful. Right below that, there is a survey screen. We'd really appreciate any feedback you have on today's session, and let us know what you might be interested in learning more about. You will be sent a recording of this presentation within 24 to 48 hours at the email address you registered with. So with that, I would like to introduce today's speaker, Andrew Ho.
Thanks for the introduction. My name is Andrew Ho. I am a program manager for Azure Cosmos DB. Within the session, I hope to really talk about how you can build real-time personalized experiences on Azure Cosmos DB. And I hope to share some key architectures that we've seen in the industry with different users. And hopefully I get you to kind of understand how Azure Cosmos DB plays a role in this and how you can get started building these type of applications. So the current state of the world today, customers have extremely high expectations for how applications should be run. Approximately 79% won't return to a slow website. About 65% will get frustrated with inconsistent device experiences. And so if one person goes to a website on their mobile phone versus going to a website on a computer, if there's an inconsistent experience, they're pretty upset with that. And lastly, about 38% of individuals won't call again if they have to repeat themselves and there's a lack of personalization. And so within this current market, you do need to build real-time experiences to exceed the expectations of customers around the world. And so how does a real-time experience and what does a real-time experience really look like, and how do you build a real-time experience? So first, a couple of real-time experiences that are live today. The first one is marketplaces. When you go to a marketplace or go to an e-commerce website, you see real-time recommendations, and you can imagine this as almost a personalization for you. What type of application should I download next? What type of mobile application should I download next? What type of games do I like? If I'm on an e-commerce site, what kind of shirt should I get depending on the shirts I purchased previously? Or what kind of items would be most interesting to me? And the goal of real-time recommendations is to build a personalized experience for individuals as well as from the side of application building to increase conversion rates. You want more individuals to download more of their applications so they try out more new experiences. Other real-time experiences that are crucial are the real-time gameplay. You can imagine when you download a mobile game and you're playing on it, what kind of real-time experiences do the users expect? How do they expect to interact with the game? How do they expect to interact with their friends and different individuals, and how the high scores work? And so real-time gameplay is also crucial, where you need individuals at millisecond latencies to see their games being updated, being changed. And all of this should depend on the current state that the user is in, the type of friends that are online. And so real-time gameplay is another crucial area. Another example of a real-time experience is real-time chat. When you're building any type of social application, you do need a real-time chat portion. Can you imagine the last time you've used a chat network? It takes seconds or even minutes for someone to actually answer back or for you to see the latest status update. And so real-time chat is crucial, and having this type of real-time experiences really elevates in an exponential way the user's experience and builds a robust, long-lasting application. And so before we dive into how this real-time application works with Azure Cosmos DB, first, just a quick recap of what Azure Cosmos DB is, because this will talk about Azure Cosmos DB and how it plays within the interaction of the architecture. So Azure Cosmos DB is a globally distributed multi-model database as a service. We support multiple APIs. The APIs we support are the Cassandra API, MongoDB API, Gremlin API, the SQL API, the Table Storage API, and the JavaScript API. We are multi-model, so we do support different types of models. For those of you who are familiar with kind of the NoSQL databases, We do support key value stores, column family, documents, and graphs. And 5 of the key value propositions for Azure Cosmos DB is that we are globally distributed, and so Azure has about 40 plus data centers in the world, and so you can imagine you can have your data as close to you as possible. We are elastically scalable, so if you need a gigabyte's worth of data all the way to a petabyte, we can scale out for you so that you can feel safe being in Azure Cosmos DB's database. We have guaranteed low latency. Especially within this real-time model, low latency is crucial, and so we are an incredibly fast database. We are a premium database, and we are built on SSDs. We have 5 consistency models. For those of you who like a little bit about databases and the CAP theorem, we have 5 different consistency models, from strong all the way to eventual, as well as 3 ones in between that really kind of revolutionize how people think about NoSQL databases. And lastly, we do have comprehensive SLAs. For those of you who are not familiar with the acronym SLAs, SLAs are service level agreements, our promises to the users. And so when you're taking a bet on any database, we want to make sure that you are comfortable and that you have the strongest guarantees. And so we do have financially backed SLAs, which means that with availability, throughput, latency, and consistency, you can feel very comfortable using Azure Cosmos DB, and you can feel that you're financially backed on all of the promises we make. And lastly, we are coming up with more models as well as more APIs. And so please stay tuned and please follow us on Twitter and all our social media channels to learn more as new updates come out. So why do I actually want to use Azure Cosmos DB in a real-time personalized experience? What types of value propositions and characteristics of the database make it so useful to build these type of real-time experiences for users? So one of the first things is, and building any type of real-time experience, the key word there is real-time. You need a database that can really keep up with users' interactions. And so we do have guaranteed low latency at the 99th percentile, which means that as you're interacting with this database, we guarantee at the 99th percentile to deliver you your reads for a 1 kilobyte document within 10 milliseconds and your writes for a 1 kilobyte document within 15 milliseconds. This is within a single data center because you can imagine that we can't put this guarantee if you're hitting us from Brazil all the way to California, just because speed of light alone, it's going to take you quite a bit of time to actually reach California from Brazil, and it's probably going to take anywhere between 150 to 200 milliseconds. Next, you want to make sure that you are highly available so that you can achieve real-time applications with robustness. There are a lot of applications today where if the database goes down, the application's down. And at Cosmos DB, this really is not acceptable. And so we make sure that we do have 99.99% availability, and that's for a single region. You can imagine that's even higher when you replicate to multiple regions. And so availability is one of the crucial parts that we really focus on, and we do replicate your data locally to make sure that you have durability and to make sure that your application is always running. Another crucial component is infinite storage and throughput scale. With real-time applications, there's a component of real-time data that tends to grow at an incredibly fast rate. And so you do need a database that can scale in terms of both storage as well as throughput. And this means that if your application starts out with 1 gigabyte's worth of data and 10 writes and reads per second, that's perfectly fine, and that can fit comfortably within Azure Cosmos DB. But feel safe knowing that if your application does go viral or your application does consume more and more data as time goes on, we do have an option of elastically scaling out so that you are supported, which means that you can fit your gigabytes worth of data on Azure Cosmos DB, and if you grow up to the terabytes, you can fit comfortably on us, and the petabytes as well. You don't need to re-architect. You don't need to make different decisions just because we are built on a scale-out model. For those of you who are not familiar with what a scale-out model is, essentially we are adding machines on so that you can linearly scale and you can grow to any number of storage you want or throughput, rather than a scale-up model where a database is scaling up because we're just getting bigger and better machines. And so with our scale-out model, you can feel comfortable growing to almost any number of storage as well as any amount of reads and writes you need. So the next question that always pops up is who's doing this today, right? Who's building on Azure Cosmos DB today, building real-time experiences, and what do those experiences really look like, and why did they choose to use Azure Cosmos DB? And so Skype powers their real-time chat through Azure Cosmos DB. They have about 6 terabytes of user data, 1 terabyte of group data, and 44 terabytes of message data. One of the key things you can imagine with Skype is they are a global application. Their users span the entire world, and so they do need a database that could span the entire world. And so Azure Cosmos DB can be replicated to any number of regions they want. And because we do have that fast latency, under 10 milliseconds for the reads, they're able to support real-time chat for their users. So users can interact with one another, have a real-time experience, and are happy while using the Skype platform. Next, this is one of our earliest users, which was the Walking Dead's official mobile game. They used us to actually deliver a real-time gaming experience. As you can imagine, when's the last time you played a game where every action takes a second or longer to actually process? A lot of users are not happy with that. The state of the world is, as you interact with the game, it has to happen in milliseconds. And so the Walking Dead's the official game uses Azure Cosmos DB. And they chose to use us because one of the key things is with any type of mobile game, you don't really know what type of scale you're going to interact with. You don't really know how fast it's going to grow. And so they wanted to go with an elastic database that could handle the amount of storage that's coming in as well as the amount of throughput they might need in terms of reads and writes. The other crucial thing is for any type of real-time experience, they wanted to make sure that they had notifications so that as your friends, as your different members of the clan you're playing with, are coming online, how do I get a notification that they are available to play with, and how do I actually interact with them? And so one of the key things is actually building on top of a database that can support this type of real-time interaction to build a better customer base that are happier with the product. Another one that uses us is Toyota. Toyota uses us for their IoT platform. They have about 8 terabytes of vehicle telemetry and about 250,000 Lexus vehicles out there right now. And you could imagine with Toyota, they want a real-time experience for their drivers. And so as their drivers are driving along, how do I give an experience where all the drivers have a personalization and more of an attachment to their vehicles? One of the key features that they were building was a OnStar type of support, which is essentially if there is a car crash, how do they immediately notify the appropriate individuals? And then if, let's say, you get a call within your crashed Lexus and you don't respond, how do they get an ambulance to you? And so it's a personalization where they want to make sure that you feel secure and safe while driving a Lexus vehicle. And in order to do that in real time, they need a real-time database like Azure Cosmos DB. And lastly, one of the customers that uses us today is ASOS. You can imagine with ASOS, they do want to do real-time personalization so that individuals who come onto their website get to see a catered list of products that are personalized for specifically them. The online fashion retailer ASOS achieves a 25% increase in annual growth and more responsive applications that deliver personalized customer experiences. And so they really look for that smarter, faster applications to help retailers or help them as a retailer. They also require global distribution for performance and availability because, as you can imagine, ASOS really can't have downtime where, if their database goes down, that their website is down. And so they need to have this durability so that they're always available, as well as their customer base spans the entire world. And so they do need a database that could span the entire world as well. ASOS handles about 33 online transactions per second with no change in latency. And so you can imagine that different holidays as it comes along, they need to scale that up. And so they need a database that is elastically scalable so they can scale up as well as down if their holiday and seasonality kicks in, because you can always imagine that Black Friday or just the holiday season for Christmas, for the winter holiday season, there's always a spike in traffic and transactions. And so here's a quick quote from Bob, their CTO, on why Azure is such a key component for the infrastructure. and the quote goes, "We can react to changes in our global customer base. For example, if we expand our marketing spend in the US, we can simultaneously beef up services to support those new customers. We can introduce new features and ramp up deployment wherever our customers are in the world." And so you can imagine that one of the key things for their CTO is that as traffic and demand grows, how do they grow as a service? How do they grow in both the database as well as their application? How do they meet that demand? And so they chose to bet on Azure because Azure is, a cloud service offering where you can actually just get new capacity, get new infrastructure to help support yourself within a matter of seconds. Here's a quick look into their architecture. You can see that their shoppers go onto the ASOS page for product details on the page. And it forks off. One part goes into Azure Service Fabric, which is their personalization decision engine. The other part goes into Azure Event Hubs, which goes into Azure Data Lake for colder storage. On the colder storage, what they do is they use Apache Spark on top of HD Insight to actually mine a lot of insights on what their users are doing and what people are doing. And so through those insights, they can pump it back into Azure Cosmos DB so that it can make recommendations and provide you details on personalizing different experiences for different shoppers. And so one of the key things for them is really delivering that personalization in real time for their users. And Azure Cosmos DB is that real-time database. So what does a real-time experience on Cosmos DB really look like? I talked a little bit about different users and customers who are using us for a real-time experience. And now I want to talk a little bit more about the architecture. How do you actually build a real-time experience on Azure Cosmos DB? What does that look like? And within this, I'll take a fictitious airline called Contoso Air, and I'll dive into 5 different components where they're able to elevate and modernize their application to deliver this type of real-time experience. I do want to mention that all of these different scenarios that I'm talking about, we do have resources online, so that if you do want to use this as a POC for your application, you can actually visit our GitHub and get the code that actually does this, and these are our hands-on labs as well. And so while I'm going through this, if anything looks interesting, please keep in mind that we do have the resources available to you so that you can actually test it out and run it yourselves. So let's take the fictitious airline company called Contoso Air. This airline is seeking to delight customers around the world with a more intelligent and responsive application. As you can imagine, this is a goal of a lot of different users and a lot of different customers. And since customers expect more from Contoso Air, how do they deliver this type of modernized experience, modernized as well as real-time experience for their users? Well, one of the first things that they can do is they can build off of a serverless architecture. They can modernize their infrastructures so that they can deploy easier, as well as the maintenance becomes a lot easier. The second thing they can do is they can do a greater customer choice and real-time notifications. The third thing they can do is intelligent predictions based off of a complex amount of data that's coming in from their users. One of the 4 things they can do is they can improve the customer awareness through event-driven scenarios, which you can imagine is a big play within airlines. And lastly, they can do responsive customer service through intuitive interactions. And so for the next couple of slides, I'll talk about each one and the architecture that can be taken. Granted, there's many different ways you can architect this, but I do want to highlight some of the architectures that we think are a good design and how it can all play together. And so 1, performance around the world with a serverless architecture. So let's say Contoso Air wants to improve the application performance for customers booking flights on the application around the world. And this is a goal for a lot of airlines as well as a lot of different users. You want to make your application as fast, as real time as possible so that as users interact with it, they have a much more pleasant and happier experience. And so this is just a simple architecture for how they would do it. And so you can see that Contoso Air has a UI tier. This is based in 3 different regions: Australia, Western Europe, as well as Japan, just because they are a global company. and then they have their services behind it which backs it up. And so you can imagine your services could be app service, web service, anything else. And they're all linked to the same Azure Cosmos DB database. And so this Azure Cosmos DB database is there for resiliency, to make sure that their application is always available, as well as for that real-time component with the speed that Azure Cosmos DB can handle. And then each flight topic can ingest data specific for each different user, and it could go into the in-person airline staff so that they can cater different experiences for the different customers that come up. And so why do I want to use Azure Cosmos DB in this instance? Well, we do have turnkey database replication across many different data centers. And so if you want to replicate to any number of data centers, it's merely just a couple clicks within the Azure portal. And it's as easy as that. And so we do make replication very, very easy. You can dynamically add or remove regions. Just because you've added another region doesn't mean that you can't remove one. And so we do have a strong belief, even in scale, that you can grow as well as you can scale down, as well as they want low latency, right? And so they want that real-time experience where their queries, their operations are taking within milliseconds, and so that all their users and customers can have that real-time experience. Next, moving closer to that serverless architecture, they can actually use Azure Functions to process the data. And so Contoso Air has Cosmos DB as the backend database, and then that could pipe through Azure Functions for automated processing. And through that processing, you can either clean up the data, you can either trigger events based off of the data that's coming into Azure Cosmos DB. And so this is a really flexible way of doing the serverless architecture, so that you can decrease the amount of management and maintenance you're doing and only really care about what the application and what code you're actually shipping out. And so some of the benefits, like I mentioned, are you do have time-based processing to clean up the data based on different business logic you set up. And you can execute serverless code that triggers on automatic events. And so Cosmos DB does have a feature called change feed. And the change feed is something that Azure Functions directly pipes into, so that if you want to trigger on certain events, you can actually set that up within a couple of clicks. And then now you have this strong business logic that's hooked up to your database, and that could trigger on any type of event that you design. Next, global distribution improves availability and performance around the world. And so I do want to emphasize that as you replicate to different regions, the data is much closer to your users now, which means that if your data just has to travel from, let's say, Western Europe to another country in Europe, it's not going to take as long as if your sole data center was in Western Europe and you're traveling to Southeast Asia. Just speed of light alone, you're looking at probably 200 milliseconds or plus to actually get across the Pacific or Atlantic Ocean. And so with global distribution, they can improve their performance, as well as they're making their database more resilient. As you replicate your data to other data centers, you're improving the resiliency so that if there is a power outage or a natural disaster, your data is still available and your mission-critical applications can still be running. And so within this simple architecture, you have your Contoso Air application, which talks to your app service, which has a lot of the logic hooked up in Azure Functions and can be connected to Azure Cosmos DB. And this is applicable to any of the APIs, and so Azure Cosmos DB can be replicated to any number of regions, no matter what the API is. And the real benefits, like I mentioned, are the customers enjoy high availability and performance anywhere in the world. The regions can easily scale, and customers demand through global database replication. And Azure Functions really helps to streamline development so that you do have that serverless architecture, and you're only really focused on the code. Next, let's say the second use case is customers want a real-time notifications as well as more choice. And so Contoso Air seeks to provide a better experience by enabling customers to have real-time status updates. And when building the real-time notifications, a simple architecture can look like this, where you have your Contoso Air application, which talks to the user, and you also have a notification service. And so as data comes in through Azure Functions to Azure Cosmos DB, you can hook up Azure Functions so that it could trigger off of different events that come into Azure Cosmos DB. And those events can go through any type of text analytics, and through an app service which routes directly to the notification service. And this is crucial if you think about different events in airlines where there's a snowstorm and we want to make sure that all the passengers of a certain flight are notified that their flight has delayed or this could have potential impact. And so customers receive instant updates on the flight status through the Notification Hub API. Although it is going through multiple services, this is happening in milliseconds, and so you can imagine that this is still that real-time notification that users expect. And you can also hook it up with text analytics to get customer feedback, and you can analyze whether they do have a happiness or whether sentiment is high for your service. Next, and this one I'll show a quick demo afterwards. And so this one is based off of intelligent predictions based off of complex data. And so flight delays and cancellations can result from a number of different factors. It can be that the scheduling of flights are happening a certain way that your flight is delayed. It can be that there is a snowstorm, or any number of effects can actually affect whether your flight is delayed or canceled. And so Contoso Air might want to enhance the customer experience by forecasting and predicting what flight delays are happening and communicating this with their customers in real time. And so a simple architecture, how you might imagine doing this, is you have Cosmos DB as your main database, your real-time database, and you can hook that up to Apache Spark. And Apache Spark can run different ML jobs to predict whether flights will be delayed or not. And then that can be piped into either an application service so that people, when they go onto Contoso Air, they can see the latest status update for their flight, or it can even be hooked up to a notification hub so that they do get alerts when flights are delayed. And you can also do that to the Power BI dashboard so that the internal customers, the people who are maintaining flights, the people who are analyzing how the actual business is running for this fictitious airline, can actually check how the flights are running. And so I do have a quick demo of this all piped in. And remember, the code is available to you, so if you do want to run this yourself or you do want to go through this lab, all the resources for this are available afterwards. And for now, let me just show you my screen. And so right now what's loading up is the Power BI dashboard, and this is hooked up to the Spark cluster, and the Spark cluster is hooked up to Azure Cosmos DB. And so right now I'm showing you just a quick dashboard made pretty quickly just to see what is the delay analysis, right? What is the average delay based off of different airlines? What's the delay based off of the city that it's departing from? And so with Power BI, you have this interactive visualization on top of your delay data that was built from Spark. And Spark is doing a lot of the heavy loading on analyzing what type of flights have the highest percentage of being delayed and by how much. And so by hooking up with Power BI, you can actually make it very easy for different individuals to traverse this data. And this is data can be coming into real time to Azure Cosmos DB. And so now I can analyze what is the delay based off of different airlines, different cities. I can look at analysis of what are the canceled and delayed flights. And I can do that once again based off of the different airlines, the different cities that it's leaving from. And I could see what is the average delay or number of delays based off of the weather, as well as what's the average amount of delays based off of the security. And so most of this data is for North America, and so you can see over here that a large part of this data is coming from the North American region. And so this is a great way where you can interact with it. And this is customizable. This is not actually a published report. This is within the Power BI desktop. And so I can actually change the actual visualizations as I want to, and I could add in different group bys. And so right now what I've actually done within Power BI is I've uploaded data from CSVs with the airline codes, because the data that is coming into Azure Cosmos DB has the airline code but doesn't have the full city. And so we did want to map it out so that you can see exactly where it's leaving from. And so you can see all this data here. You can see the delay by the city. And so you can see what cities do I want to avoid, where are most of the delays happening, what airlines are causing these delays, what type of flights will I have a more pleasant experience. And if you are the kind of fictitious Contoso Air, you can use this in your advantage to actually make sure that you optimize different flights. You can make sure that constantly delayed flights are targeted so that you can make improvements, and you can always make that better, and you can make your business better, and you can make your customers happier. And so over here, you can look at the airline comparisons just for what the delays are depending on different airlines. And this is all done with Power BI, Spark, and Azure Cosmos DB as that backend database. And so over here, this is the departure delay by origin cities. And lastly, the segmentation on the graphs on what the origin cities are and destination cities. And so Power BI has an awesome visualization so that you can see what does the graph look like for flights coming from a certain city and where are they going towards. And this is a great way to interact with the data and make it super easy to figure out how the flights are being actually traversed and what the flights are like, and whether certain delays are actually causing or certain delays in layovers that are actually causing overall delays for different flights. And so you can bring this complex analysis into Power BI so that it's much easier to learn from your data and use your data to effectively get business insights and to elevate how much you're able to do within your business. And the next thing I do want to show is this is the Jupyter Notebook. Actually, this is the Jupyter Notebook that actually has Azure Cosmos DB hooked up with Apache Spark. And so we do have the jars available for you so that your Spark clusters can ingest data from Azure Cosmos DB. And this is actually the lab on where you can build this yourself with just a couple of steps. And all the materials are there for you. And it's all hosted publicly on GitHub. And we do want you to use this so that you can really see what the potential is and how simple it is to connect this all together with just services based in Azure, Spark, Power BI, and Azure Cosmos DB. And so going back to it, and so this is just one of the things. As a friendly reminder, once again, all the scenarios I'm talking about within this presentation, they all have a hands-on lab associated with it. And so if you do want to explore certain avenues, please feel free to go to the hands-on lab and run it through yourself just to see what the interaction is like and how you can build these type of complex services with just a couple of steps. And so next, let's say that Contoso Air wants to improve customer awareness through event-driven scenarios. And this is a big trend these days with a lot of users is how do I have event-driven scenarios so that my applications react dynamically as different events are triggered. And so events can be, delays for this airline, gate changes, but it can also be an individual who goes onto an e-commerce site and looks up, a different a shirt of a certain color of a certain brand, and that can be an event, and that event can trigger, retraining a model or looking for what are similar items, and this event can also be within different games where if you have an individual playing a mobile game and one of the events that is triggered is they friended a different, user, what does that actually mean? Does that mean that now we want to trigger notifications so that as that different friend gets different statuses and different types of awards within the game, that they should be notified to bring a little bit of more of a competitive aspect to the game? And so you can think of this event-driven scenario in the context of many different applications. And so for Contoso Air, we'll focus on airport gate assignments, and they are changed occasionally with very little notice, which leads a lot of customers to confusion and frustration. I'm sure a lot of you have experienced this when you're doing a flight that has a layover and it turns out your layover gate has changed, and so you're quickly running across the airport to find out which gate should I go to. Did my flight leave yet? How do I make sure I'm there in time? And so Contoso Air needs to quickly learn and communicate unexpected information from a diverse group of data sources to maintain customer satisfaction. And so one of the architectures you can imagine is that they have the authorized staff, which could be the individuals who work for Contoso Air, who actually go to the Contoso Air application, and through there they can publish different gate changes, and that can be hooked up to app service, which gets hooked up into logic apps. And logic apps can actually have Azure Functions trigger on it, and so Azure Functions can notify the individual customers and passengers of gate changes, terminal changes, lost luggage, or the status of their luggage. And so this is kind of a key way to make sure that you build that type of real-time interactions with your users so that they feel comfortable using your product and they feel comfortable flying on this, Contoso Air. And so some of the key parts of this solution is that the terminal gate information will be quickly received and retrieved from Azure Cosmos DB through Azure Functions, and customers receive a real-time update when events are triggered through the Azure Functions code. And so this is a super simple architecture on how you can build this type of real-time interaction between users as well as the fictitious airline or whatever the company that you choose to kind of implement this for. And then lastly, the responsive customer service through intuitive interactions. And so as any type of business, you are looking for a lot of customer feedback to understand how happy are your customers and users, will they use our service again, and how do we make sure that we optimize their happiness so that they do thoroughly enjoy using the product. And so airlines often struggle to provide reasonable customer service and wait times or intelligent ways to gather and share customer feedback. And so you can imagine that this problem is twofold. One is, how do I actually address all the customers and their specific needs in an intelligent manner that scales? And then the second one is, how do I actually gather the customer feedback and parse it so that I understand whether customers are having a pleasant experience or negative experience while using Azure, while using the Contoso Air. And so Contoso Air seeks to automate these services and enable intelligent feedback to improve customer satisfaction. And one way to actually build this out, you can imagine, is to actually hook it up with intelligent bots. So the customer goes onto Contoso Air, which is kind of that application, which is backed by app service. And app service is backed by Azure Cosmos DB as that real-time database, that highly available real-time database. And then app service can actually hook up to Azure bot service, and Azure bot service can interact with Skype bot service and Big Maps. And so the key things here is that you are using the bot service to interact with the customers, and so that they can actually have real-time customer support. The bot service automation unburdens the customer service resources. This is one of the canonical problems within most service-based operations, where you want each individual to be empowered to do more, be more cognizant of how much time is being spent on different actions and how can we make it easier. And so building this type of infrastructure really empowers them so that they're able to utilize 100% of the time to focusing on how to make customers have a more pleasant experience. The other one is bot services provides faster flight scheduling, reservation updates, and related services. And so the entire life cycle of someone who books a flight, how do you make it much easier and how do you make it much faster? And so building this type of real-time application enables users to be able to leverage a real-time infrastructure so that they do have a more pleasant experience with flight scheduling, reservation updates, cancellations, and all of that. The next aspect is, how do we get the feedback from users and how do we really understand whether they are feeling happy about the service? How do we get this kind of sentiment analysis through an intelligent way? And so the architecture that we propose here is just your Contoso Air application is hooked up to logic apps, and that's hooked up to the different cognitive services APIs, which is your emotion API, your text analytics API, which can be hooked up to Azure Functions, and that can feed directly into Azure Cosmos DB, which is your root database. And then from your root database, you can connect it to any different UI so that the different staff members or different stakeholders are able to see whether people are happy with the service, whether people are happy with flights, whether people are happy with how their overall flight has gone. And so all of these services are available to you within Azure, and so it's pretty easy to hook up. And so you can actually delve into more insights on what their customers are giving back to you. So the key parts to this is Bing Speech API converts customer voice data into written feedback, and so you are able to pump that into Azure Cosmos DB. The Emotion API is able to generate ratings based off of different users' facial expressions, which is very cool, which means that as you can see individuals, whether they're happy or angrier during the flight, you can make it a priority to make their flight experience better. And Text Analytics is able to codify and analyze the customer feedback and their text so that you can analyze whether they're having a pleasant experience or not. And all this data can go into Azure Cosmos DB so that you empower the decision makers as well as the stakeholders into whether things should be adjusted, things should be changed, what parts of the flight are particularly painful for the users, and how do we improve it to make it better. And so with these kind of 5 different aspects, Contoso Air is able to really modernize and build a real-time experience for their users. And some of the key criteria that they were able to benefit from using Azure Cosmos DB was the consistency and performance anywhere in the world. Imagining Contoso Air as a global organization, you can imagine that it is really important to be anywhere in the world. Granted, just because we can be anywhere in the world, we don't, we see that a lot of users also replicate within a single region. And so you can imagine that within the continent of the North America, you might want to replicate from East US and West US just because your user base is US based, and you want to make sure that no matter which side of the North America you're on, either East or West, that you have this fast experience. Next, they're able to make sense of data from a variety of different sources. We don't enforce schema, and so you can imagine that if you do have a varying amount of schema from different sources, they can all go into Azure Cosmos DB with ease and in an incredibly fast rate. We do have real-time predictive analysis to forecast what's next, and so you can hook it up with that cognitive services as well as more so the Spark ML, so you can predict what's happening with the flights. Instant updates hooked up with notifications so that you can give a real-time experience for the user so that they can see what's happening with their flights, whether there are gate changes, what's happening with their luggage. And lastly, you can automate and you can put intelligence into your services so that you can better understand how your users are doing. And so all of these 5 things really modernize and build a real-time experience that users expect from applications these days for Contoso Air. It doesn't mean that one of these things is contingent on another. It just means that for this example, I've taken 5 things that they can really improve on and really showcase how they're able to make a better interaction model with their users. And so I know it definitely looks a little bit complex, but this is the overall architecture, how you can imagine combining all the different things that I've talked about. And so building one by one, it's rather simple. Starting from just building this all together, it does look a fair more complex. But this is kind of the overall architecture. You can imagine that this is happening behind the scenes for Contoso Air, and they're able to deliver all of the services as well as all of the real-time personalization that I mentioned before. And so if you have the time, please feel free to walk through this architecture. Look into just what components really make sense for you. What components is something that would really kind of bring that real-time personalization for your use case, for your specific use case. And like I mentioned before, each one of the components I talked about are on GitHub. They are separated out so that if you want to focus in on a specific one, you can. And lastly, these are some of the resources available to you. You can try Azure Cosmos DB for free, and you can really look into how Azure Cosmos DB can deliver you that real-time performance you're looking for. Sign up for a free Azure account so that if you want to incorporate the other Azure services as well, you can. Please feel free to download the Azure Cosmos DB emulator. The aka.ms link is missing an S after Cosmo, so please make sure you put in another S after that. Enhance your skills with hands-on labs, and this is what I'm really talking about, where we do have those hands-on labs so that you can build these out yourself and get a feel for how it actually interacts with one another and how simple it can be. And if you want to just skip the hands-on lab and not spin up a VM, you can go directly to the hands-on lab source code, which is divided into, I believe, 6 or 7 different labs, and each one targets a different aspect that I talked about. And so feel free to really zoom in onto the different ones you want, and take the code snippets you want to use. That concludes my portion on real-time applications and real-time personalized experience with Azure Cosmos DB. And so we'll open it up for a Q&A. Cool. For the Q&A section, I'm gonna just go through some of the interesting questions on within the chat window, and I'll hope to answer some of them. The ones that I don't get to, we'll try to answer it through just the chat, so actual text. And so one of the ones that are key here is there a sample solution available to play around with? And so just seeing it again, all of this is available to play around with. And if I go back to the previous slide, I do really recommend going to the last 2 links. And so you can see that the Handson Lab source code is a great place to start. It's a simple way of just seeing exactly whether what the code looks like, how the interaction works, and it's a simplified form of it. And so it's a great place to get started, and it is a sample solution for you. There's another question out there on, do you have any documentation for Jupyter? So the interaction with Jupyter Notebooks is pretty easy, just because Jupyter is that kind of runtime environment for us. And so all it really takes is just uploading jars into Spark, and then Spark is actually connected to the Jupyter Notebook. And so to actually open up the Jupyter Notebook to connect to Spark, it's within the Azure Management Portal. You click on the Notebook section, and you can actually open it up and be hooked up directly to your Spark cluster. And so any code you execute there is actually can be executed in your Spark cluster. What is the name of the GitHub repo? So the GitHub repo is under Microsoft/developer immersion data. And so please feel free to look around. And I believe there's a lot of good labs for not just Azure Cosmos DB, for other services as well. And so please feel free to look around at the other services that might be there, just to see whether those actually fit your need as well. Where can we download this Contoso Air demo? So the Contoso Air demo is available to download through that link I just mentioned, the GitHub repo. I believe it's not the full solution, but it's only about 6 steps to actually connect it all together. And so it's very easy to get that running. And that's each component of the Azure Cosmos DB is in a separate lab. And so you can just download it all, and then you can build it yourself. And it's pretty quick. Definitely something I recommend. One of the other questions that just came in is, does Cosmos DB hold petabytes worth of data? Yes, Cosmos DB does hold petabytes worth of data. Like I really mentioned, this is a scale-out database, and so we are designed to scale out to petabytes of data. And it's really no challenge for us to scale to that magnitude. One of the questions is, can any of these real-time scenarios be done with SQL Azure and other things, or is Cosmos DB the only way, as it can be very expensive? So one of the things we do recommend is really understanding whether you want to hold your hot data in Cosmos DB and then your cold data in something like Data Lake. And so Azure Cosmos DB is built on SSDs. And so SSDs, if you want to store your hot data, things that need to be in real time, we really recommend coming to Azure Cosmos DB because that's where the SSDs give you that premium experience. While if you have cold data, let's say data from 5 years ago that will be rarely queried upon, then we recommend going to something like Azure Storage, something that's on hard disk, something that is much friendlier for you guys, just in the long term. Okay. One of the other questions is, how do you monitor and analyze overall system state? And so within the Azure portal, we do expose metrics so that you can see exactly what the kind of state of your application or database is. And so we do expose to you the different HTTP calls you're getting, as well as how many resources you're consuming, how much data storage size you're using. And the nice thing about this is you can actually use Azure monitoring to hook it up to different alerts so that you can alert on whether your database is running too hot or whether there's too much storage and you want to purge some of it. And so definitely something that is available to you. Okay, some other questions. Where will I get this code for Power BI demo, which you showed? The Power BI demo, once again, it's within that GitHub repo, and so you can definitely download it from there, and everything is available to you. And I think that the actual reports are built out for you, and so all of the things I kind of showed you will automatically be there. And it's a great place where if you want to play around with the data and see what else you can do with it, it's all there. There's a question about the hybrid approach. So if you do want to take a hybrid approach with an on-prem being replicated to Cosmos DB, one option you can really think about is using some type of data migration service, maybe ADF, or within the application layer, writing it twice, one to your on-prem and one to your cloud. And both are pretty valid strategies. Or the other option is you can go directly to Cosmos DB and you can use our change feed and functions to actually write it back onto on-prem. And so this is a way of really keeping your data within both the cloud as well as on-prem, and you can actually have it pretty much in sync with the dual write approach or change feed or anything you choose. So yeah, so one of the key things I do want to mention is this webinar is a part of a series, and so definitely sign up for the other webinars that are happening weekly on different aspects of different services within Azure and Cosmos DB. I believe the next one is on our Graph API and Table API, which I really recommend if you're interested in how graphs are set up and how you can use it on Azure Cosmos DB, and what the interaction model is like and how you can get kind of the full power of a graph database. The other ones that are coming up are, we do have a change feed one later on, as well as a Spark connector one for data science. And so, this is definitely a little bit more of a high level one, and we will be diving a little bit deeper into different aspects of this through the other webinars. And so please sign up for the other ones because we do want to give you a deeper insights onto all the different components that Azure Cosmos DB has. So the slide deck will be available to you, I believe. And so this slide deck will be available, so please feel free to download it. I also believe that the webinar is recorded and everything, will be available to you. So if you want to rewatch different aspects of it, please feel free to. Yes, the link to the emulator is missing that S, and so please make sure that you do put an S after Cosmo. So it's Cosmos. Sorry, just a quick mistake on my part. But that will give you the emulator. The emulator is based on Windows, and so definitely if you have a Windows device, emulator is a great place to get started with Azure Cosmos DB. So if you want to migrate the existing data to Azure Cosmos DB, there's a couple of different ways. You can use different migration services, and so there are different services like ADF, which we'll be able to migrate from. We do have a data migration tool. This data migration tool is able to read data from a number of different sources and actually pump it into Azure Cosmos DB. So that's another option. And it also does matter whether you're doing a live migration versus a still migration. Live migrations, as everybody's well aware, is definitely a lot harder just because you are trying to move production data. So when moving that, you do have to think about how do I do the live migration. Generally, we recommend doing the double write and then flushing out all the historical data for live migrations. But yeah, feel free to reach out to us if you have additional questions on that.
All right, thank you, Andrew, so much for that great presentation. It looks like we are nearing the end of our 60-minute time limit, so we're going to have to wrap it up today. So as I mentioned earlier, we do have a few resources on the upper right-hand side of your webinar screen. You can try out today's demo, and there are just some other resources that you will definitely find helpful. Below that, we would really appreciate it if you took a moment to fill out a few of those survey questions that we've posted. This will really just help us know how we did today, learn a little bit more about you, and learn what you are interested in learning more about in the future. So with that, our time is up. We'd like to thank you again for joining us today. Have a great day.